Well, good morning, and thank you very much for inviting me and for your hospitality and for all the hard work you do. Without the PAS, this story would never have advanced at all in any direction. You should be very grateful to them. Basically, I'm not a hematologist, I'm a gastroenterologist, so perhaps I shouldn't be speaking here at all. And the reason I got involved in B12 was because so many of my patients with gut diseases developed vitamin B12 deficiency for which there was no obvious reason. And here is, just to remind you of the bits of the gut we're interested in, food is swallowed, goes to the stomach, and there, the B12 in the food combines with something called intrinsic factor, and that enables the B12 to be absorbed lower down in the small intestine here in the ileum. And normally the small intestine doesn't contain any bacteria, it's virtually sterile. And then food residues go into the large bowel here, which is stuffed with trillions of bacteria. Every time I open the paper these days, I seem to read someone saying, we have more bacterial cells in our body than we have human cells, and this is absolutely true. And they are there, and of course we're all well aware that if you have a salmonella or horrible bug, Campylobacter, you get raging diarrhea or something like that. But mostly, medical practice has suggested that if there isn't an infection, that is just a tube leading to the outside, food passes along, water's absorbed, and that's it. But we think it's far more complicated than that nowadays. And so, to remind you what we've already heard this morning, I don't want to go into detail, if you've got antibodies to the stomach, press that the wrong way, then you don't get the intrinsic factor and reduced stomach acid, and B12 is not absorbed, and this is classical pernicious anemia. But also you can get B12 if you get bacteria, B12 deficiency, if you get bacteria growing in the small intestine, which should normally be virtually sterile. And this is secondary to small bowel disease, such as swellings or narrowings, and this enables bacteria to survive there. And my problem was because I found that, as all of us here well know, that some people require more B12 than the books suggest, and the chronic fatigue is relieved by the B12. And the very interesting thing, this was Martin's survey of his members, 72% of his patients with this problem also had diarrhea. And I think this is a big clue as to what may be going on. Well, it certainly pushed me in one direction. And here's just to show, one of my students did this. This is to show chronic fatigue, various symptom collections. I won't go into them because we haven't got time, but you see the blues are normal and they have high levels. The B12s without treatment in yellow, B12 deficiency reduces your energy. If you have shots of B12, the red ones, it improves, surprise, surprise. Now this is one of my patients. Patient coming with diarrhea, could find no cause for it, and had B12 deficiency. And lo and behold, here was the x-ray we did of the small bowel. I can tell you that that is absolutely normal. And the antibodies to intrinsic factor were not present. There was no sign of achlorhydria, any problems in the stomach. And yet this patient had a very low B12 level and got much better when we treated him. And this made us think more about it, particularly in review of what goes on with these patients with diarrhea and B12 deficiency. And what I want to tell you about briefly is what goes on in the small bowel. After digestion in the small bowel and absorption of nutrients, food passes into the large bowel, and there the bacteria that I was telling you about ferment these molecules. And the things that get fermented are starches, fiber, as in your wholemeal bread, some fat and protein. And we get a lot, gastroenterologists see hundreds of patients who have abdominal pain associated with an abnormal bowel habit, fatigue, bloating, wind and misery. And these people have abnormal fermentation. And We first showed this 20 years ago now. It was all published in The Lancet. But this is done by one of my research fellows. This is patients with IBS and patients, standard control, healthy patients, were treated by being put into an airtight tent. And for 24 hours, we measured all the gas that came off. And he supported Norwich City. So hydrogen is in green, and the yellow for the Canaries is methane. So here you see our patients with IBS producing masses of hydrogen, and this is our controls who are perfectly well on the same diet, and they produce much less hydrogen. And when we put our controls onto the sort of diets we treat irritable bowel with, which work well in 50% of cases, no significant effect you see in our controls, but when we get to the patients, there's a dramatic change. The reduction of hydrogen production falls to 1/8, and their wind goes, and their pain goes, and the diarrhea stops. Now, that was it's easy to measure hydrogen, no trouble at all. But since then, we've taken this further, and using very complex techniques such as gas chromatography, mass spectrometry, and with something called metabolomics, which is a very complicated computer system for analyzing different chemicals, we can look at a batch of 200, 300 different chemicals in a biological fluid, blood, urine, stool, whatever it may be, and we can see patterns. And we can see different patterns in gut diseases. And this we can use if we want for diagnosis, although these complex tests are a bit expensive. But this is showing that in these patients, this bacterial fermentation in the large bowel, which everyone has taken for hundreds of years to be unimportant, can in fact crucially go wrong. And the things that may make it go wrong are particularly infection, overuse of antibiotics, radiation, anesthetics and surgery. Various things in ordinary everyday life can trigger a change in the gut flora. And this is just to show how the bacteria change. This doesn't look very exciting because these numbers are on a log scale. So here we have healthy volunteers. Here we have patients with IBS. Don't worry about this. This was another study we were doing which doesn't involve B12. And you could see that in the healthy, this was the total number of bacteria that don't use oxygen, that's anaerobes. In IBS, they're increased, and 9 to 10 doesn't seem very much, but on a log scale, that means there are 10 times as many. And when we look at these enterobacteria, which we think are the villains of the piece, it doesn't matter, it's just we now have one group of bacteria we're aiming at. You'll see they were 10 to the 7 in the healthy ones and 10 to the 9th in the IBS. That is, there's 100 times as many of that sort of bacteria as we would expect. And this is involved with the production of a lot of abnormal chemicals, alcohols, aldehydes, the ethyl esters of fatty acids, indoles. It's very, very different. And when we correct the patients, this goes back to normal. So why might this lead to vitamin B12 deficiency? Well, there are some pointers from what we see in those patients who do have overgrowth of bacteria in the small bowel. And those bacteria have a very high affinity for B12. If you put B12 with them in the small bowel, they'll take it up more readily than will the cells of the intestine. So the body can't compete with the bacteria to get hold of that B12. Oops, my thumb's too big, I'm sorry about that. B12 absorbed by the bacteria is not released, so once they've taken it, it's lost to the body, it can't be used. Now the bacteria that grow in the small bowel in this condition, which is well described and recognized by all doctors, they are the anaerobic gram-negatives. That is, the term is facultative anaerobes. They're really oxygen lovers, but they manage somehow to survive in the gut where there's very little oxygen. And that's the same sort of bacteria that we see in the large bowel in IBS. So could this overgrowth of these bacteria in the large bowel be increasing the demands that the patients have for B12? So just to summarize that, if B12 deficiency, maybe your undigested residues going down the bowel to be fermented in the large bowel. If you've got normal bacteria, all goes well, you don't form these horrible chemicals I mentioned, and everything is fine. But if you've got this overgrowth of these enterobacteria, produces funny chemicals, some people may have a genetic resistance to that, but if they're not, could these bacteria be taking up the B12 and causing deficiency? And that's what, with Martin, we have been investigating, and we want to know if the bacteria in the bowel, in these patients who don't have classical pernicious anemia, who don't have small bowel disease, could have an abnormal microflora. And in particular, is there overgrowth of these enterobacteria as in IBS? So I hoped when this was first discussed that I'd present the results today, but sadly we've not yet quite got there. We need patients with high and low B12 requirements, i.e. some can have just one shot every 3 months, some have to have a shot more frequently than every month. And of course we need normal controls. And to look at the metabolites being produced, we have a sample of urine. The metabolites are absorbed into the blood, passed out in the urine, and we can measure them in the urine very easily. And that is a sensitive index of changed bacterial activity. Now, the sad thing is that we've got all the patients, high B12, low B12 requirements. We're still looking for normal volunteers who are willing to have a B12 test. So anyone who would like to volunteer, see Martin or Mike, yes, sorry, and we'd be delighted to get those last few. Then in January we can get the analysis done. This idea is a hypothesis. It may not be true. We have pointers to suggest it's worth doing, but only when we get the results we would really know. But in a nutshell, fermentation is a major pathological importance. This year we've published a paper showing it's abnormal in bowel cancer, and also that it's abnormal in autoimmune disease. The one we studied was immune thrombocytopenic purpura, but both were abnormal with abnormal gut flora. And this analysis for bacterial metabolites is a very sensitive way of picking up abnormalities, but we need further work to confirm this possible role. And I hope perhaps next time we speak, I'll be able to tell you the results of Martin's and my project. Thank you very much.
Thank you, Professor Hunter. We've got time for one question before our break.
Is there any way we can go and see what you've just shown us on there, so we can sort of look at it and absorb it?
They would like to look at it again. Haven't you? You've got that record on. Can you tell them how to get hold of it?
It'll be on the website in the next few days. All the presentations will.
Sorry, I went very fast through some complex things, but they only gave me 10 minutes, so...
I think we'll get one more question.
Given that I imagine many of us will want to prevent as much as cure, and on your slides you showed the control diet of your so-called normal people, could you give us any idea of what that control diet might be, and ways that, if not helping ourselves, we could help others who may simply be at the IBS stage at the moment and not yet moved on to the B12 deficiency stage?
Well, yeah, first I should emphasize that we use the diet for treatment. The diet doesn't cause the problem. The problem is the change in IBS, is the change in the bacterial flora, and antibiotics and infection are the major causes of that. But the diet, there are several diets now available for use in irritable bowel syndrome. The one we prefer at Addenbrooke's, we get 80% success with, is a low fiber gluten free diet. That doesn't mean to say that gluten is bad for you. If your health, gluten is fine. I eat gluten all the time. I'm not worried about it. So I'm not implying that you should follow Gwyneth Paltrow and cut out gluten from everything. The diet itself will not protect you if you get an infection and that changes the balance of your bacteria. There are a lot of other diets available. Some of you may have heard of FODMAPs, which the Australians have popularized. Some people use I've just forgotten what it is, the specific carbohydrate avoidance diet. It is particularly starches and carbohydrates that lead to difficulty, and gluten makes it worse because gluten is very difficult. Even the normal human gut cannot completely digest gluten, even if you don't have celiac disease or any of the other things we mentioned about. You can still show it's coming through and being fermented. So if you're healthy, eat what you enjoy. Obviously, don't put on weight, eat a balanced diet, not too much fat, etc., etc. But I don't want you to think that by following the wrong diet, you might develop B12 deficiency. Have I made that clear?
Thank you.